Hello students. So today discussion is the next part of metals and non-metals. So we are going to discuss about alloys, amalgams, corrosion as well as non-metals, physical properties and chemical reactions. To start the discussion about alloys. Students, what are alloys? Alloy is a homogeneous mixture of two metals or two or more metals, sometimes even non-metal also, that is called as an alloy. An alloy is a homogeneous mixture of two or more metals or a metal and a non-metal. It is prepared by melting the main constituent metal and then adding the definite proportions of the other elements. So also in the molten state, this molten mass is uniformly stirred and cooled to form a solid mass. This is known as alloying. So what are the applications of alloys? What are the uses of alloys? Why do we need to do the alloying? Everything we'll discuss. First of all, what is an alloy? It is a homogeneous mixture. What's the meaning of homogeneous mixture? Completely mixed. Completely mixed. Yes or no? And according to the definition, it is saying that when a metal is mixed with another metal, for example, gold, silver, both are solids, right students? How can we mix both of them and how can it be a homogeneous mixture? Here the point says clearly, this process is involved in the molten state. What is molten? We need to melt the gold into liquid state, copper into liquid state, then mixing it. Understood? Then liquid, that is molten state of gold and copper can be mixed uniformly, right? That can form a homogeneous mixture. That mixture is called as alloy. And one main point is, students, is this process, is it a chemical combination or a physical combination? That means a metal and a metal or a metal and a non-metal, are they physically combining or chemically combining? The point is very clear, students. The metal and a metal or a metal and a non-metal, they are not combining chemically. They are combining physically only. That means the atoms of other metal get into the spaces between the atoms of one metal, or if it is a non-metal, into the spaces between the metal atoms. That is called as alloying. After alloying, there are different properties. But principal element doesn't changes. Principal elements which are present in that mixture doesn't changes. Chemical composition never changes. For example, steel is a combination. It's a mixture of iron, chromium, nickel, carbon. So once if all these are mixed, we can get a steel. Is that steel can we write a chemical formula? No. Still iron is there. Chromium, nickel, carbon, different types of steels are also there. So student, that's what the point is. It's a physical combination. Okay, that is why it is called as a mixture. Homogeneous mixture. What's the meaning of homogeneous mixture? Completely mixed. Do solids mix? No, in the molten state. So first of all, look at some of the examples and then we'll discuss about uses and applications. Brass. It is an alloy of copper and zinc. Bronze, copper 88%, tin 12%. Gold, 22 karat gold. Have you heard about 22 karat gold, students? It is a mixture of gold. Sometimes gold and copper and even sometimes gold and silver also mixed. The reasons I'll explain. Solder, it's a mixture of tin and lead as well as antimony also. All these alloys, different alloys have different uses. One example I'll give you. For example, students, iron is there. Can we use iron? Iron ship is there. What will happen to the ship? It is made up of iron. What will happen, students? The ship will undergo rusting. Yes or no? The ship will undergo rusting. Some vehicles are there which they used to go in dirty roads, on wet roads, wet lands. So in that case, if it is iron, then what will happen? The quality of the material, the car body will be rusted. If it is rusted, the strengthness of the metal will be gone. Yes or no? Then if we mix that iron with a different metal, we'll get a separate alloy. For example, steel. Is that steel? Can it get rusted, students? No. Can we eat food in the iron plate? What will happen? It will undergo rust after some point. Why? After cleaning, yes or no? The iron becomes iron oxide. Can we eat on that plate? No, it's not good for health. But what about steel? Steel also contains iron. Is that pure iron? No. Iron is mixed with other metals and non-metals. That combination is called as alloy, and that is a use. We are getting rid of the corrosion or not? That's what, like that there are different uses are there, different applications are there. Look at here, metals are alloyed. What is the main purpose? Increases the hardness of the alloy. For example, let us take the same example, iron and steel. Some students are thinking steel is a different element or a new compound. No, it's a mixture of Iron, chromium, carbon, nickel. If it is tungsten, that is called as tungsten steel. So different types of steels are also there. So now answer students, which is more hard? Iron is hard, right? But comparatively with steel, which is more harder? Steel is more hard than iron. That means students, to increase the hardness, definitely we need to alloy the process. Sir, why do we need this hardness? Why? Because students, big machineries are there. Yes or no? They're also made up of this metal only, na students. For that purpose, definitely hardness is one of the main factor. So that's why for increasing the hardness, this alloying is useful, and increases the tensile strength also. Heavy machinery which can able to withstand heavy weights. So that is tensile strength in order to withstand heavy weights. So that increases the tensile strength even after alloying. So iron or steel, which is having more tensile strength, students? Steel is having more tensile strength. So to increase the hardness, to increase the strength of that particular material also, alloying is a best method. Lowering the melting points. Lowering the melting points means, for example, mainly for welding purpose. For example, solder. In the previous slide we discussed about solder, which is an alloy of tin, lead and antimony. The mixture is having less melting point than the constituent metals. So we can easily weld, yes or no, by the normal temperatures only. So for welding purpose, this factor is one of the most useful. And modifying the chemical reactivity, students. How can we modify the chemical reactivity? Modifying means we are not changing the chemical reactivity for sure. For example, let us take sodium. You all know the reaction between sodium and water, yes or no? What will happen when you drop sodium in water? It's a highly explosive reaction. Sodium suddenly becomes into sodium hydroxide and hydrogen gas is released, highly explosion reaction, yes or no? Sodium is mainly used in the organic synthesis reaction as well as for the production of many sodium compounds like sodium carbonate, sodium hydroxide, many compounds are there. If this compound, if this element, if it is highly reactive, students, if it is violently reactive, so look at the lab, in the lab scale, so is it comfortable to handle the sodium? No. If it is violently reactive, what will happen? The lab apparatus will break, yes or no? It's not so comfortable, it's not flexible to do that reaction. Now, if this sodium is added to mercury, that is called as sodium amalgam. That is also an alloy. Mercury is a liquid metal, sodium is a solid soft metal, both are mixed. Still sodium is changing? No, still sodium is there, mercury is there. Now this sodium amalgam, if we use in the chemical reaction, students, sodium is reactive, mercury is a moderately to the least reactive metal, it is not reacting. So sodium is reactive. The sodium which is present in the mercury reacts, we can get the products, but what is the changes? The reaction is not highly exothermic reaction. The reaction is not highly explosive reaction. That's what we need. SR, in order to comfortably handle that metal, which is better to handle, the pure sodium or the alloy of sodium? Alloy of sodium is better. Why? Because it's not explosively reactive like the normal sodium. Understood? This is one of the advantage. That is what the reason of modifying the chemical reactivity in order to handle in a comfortable way the metals. So increases the resistance towards the corrosion. We can say the same metal with iron. Yes or no? Iron easily undergo corrosion. Easily means not suddenly, not quickly in a day. It takes months and years to undergo corrosion. But ultimately, what happens? It weakens the strength of the metal. Yes or no? Why? Because rust is a porous material, it's a flaky substance, it falls down, ultimately it will become a hole on the metal. Instead of taking pure iron, if you take an alloy of iron, then does it undergo rusting? Never. Understood? That is the advantage. So these are the main applications, students. Why do we need to alloy? Next, amalgams. First of all, the clarity is amalgams are also alloys only. Then what is the difference? Why separate slide for this? The separate discussion is because, students, there is one common component, there is one common metal which is present in these alloys, a separate alloy. The common metal is, students, the common metal is mercury is one of the common component. That means if sodium is mixed in mercury, we can say sodium amalgam. If magnesium is mixed, magnesium amalgam. If gold is mixed, gold amalgam. If aluminum is mixed, aluminum amalgam. Every alloy, you already know, has its own particular use, has its own applications. Understood? I already explained about sodium amalgam in the previous slide. So what are amalgams? Amalgams are also alloys. But what is the speciality? Nothing special. All the amalgams have one key component, that is mercury. Key component, that doesn't mean it is major component. Mercury is common in all the amalgams. Understood? So it is an alloy in which mercury is one of the component, but it is not the major one. Most of the metals form amalgams with mercury. Iron and platinum, this is the main point, students, you have to remember. Iron and platinum are exceptions. Amalgams may be solid or liquid. These are employed as good reducing agents. For example, sodium amalgam, magnesium amalgam, reducing agents. What are reducing agents, students? What is the meaning of reducing agent? Themselves they undergo oxidation. They makes opposite element or compound to undergo reduction. Understood? So pure sodium also can be acts as a reducing agent. But what is the problem with pure sodium? It violently reacts, which we don't want. Understood? There we use this sodium or magnesium amalgams, right? Next, corrosion. We are talking about rusting in the previous slides of alloys. What is rusting, students? In general, rusting can be defined in terms of corrosion. Rusting is a process of corrosion only. The surface of some metals gets corroded when exposed to the moisture for so long time. This is called as corrosion or rust. This corrosion in terms of iron is called as rust. This corrosion in terms of silver is called as tarnishing. Different names are there, but ultimately the same process. What is happening? The upper surface of the metal, when exposed to the atmospheric gases, moisture, carbon dioxide and all, what will happen? A oxide layer will form on the upper surface. That means a color change is happening. Why the color change is happening? That means this metal is reacting with the atmospheric gases and it forms a new substance. And this new substance, is it still hard like metal? No. Iron oxide, both are same? No, absolutely not. Iron is a strong metal element. Iron oxide is a compound, it's a powdery flaky substance. Understood, students? That process is called as rusting. As a whole, the process is called as corrosion. So you can look at the image, the rusted iron, old. So is this process takes place like instantaneously? No, it takes place some months and years also, the whole rusting process. For rusting, what are the essential components? Water, H2O and oxygen, moisture. Next, prevention of corrosion of metals. How can we prevent? First of all, why do we need to prevent the corrosion? You already know the point. Why? Because, students, rust is a flaky substance. Once it forms, it falls down. If it falls down, what will happen? Inside iron metal again exposed. It undergo rust, falls down. Again inside iron metal exposed. Ultimately, what will happen? A hole will appear. Yes or no? That weakens the strength of the particular metal. A ship undergoes corrosion, rusting. What will happen? It will sink. Yes or no? Because of the hole. A bridge undergoes corrosion, it will collapse. Got the clarity? Definitely we need to prevent the corrosion, students. So coating with oils or painting, mainly machinery things. The machines, the machinery components which are made up of iron, mostly coated with paint or oils. Even the agriculture tools also. Yes or no? Grease. So then what will happen? The metal is not exposed to the moisture, so rusting will be stopped. Even for example, vehicle chains are there, no, students? Vehicle chains, connecting chains are there. So every time we need to oil the chain, otherwise what will happen? Rust will happen, right? For them we used to coat with oil or painting. Galvanization, this is one of the key process. Galvanization is coating an iron with metal called as zinc. With zinc, that is called as galvanization. Even with tin also we can do that coating. Why? Because, students, sir, why is zinc? Is it not reactive? It also reactive. It forms an oxide layer which doesn't falls down. Like iron oxide. If it doesn't falls down, if it remains as it is, then what will happen, students? Now, anything happens, is the iron inside iron exposed? No. Understood? For example, mainly this is adopted in some bridges or electric poles. Have you seen the railway bridges? What is the color of railway bridges or railway poles? Mostly silver color. Yes or no? Why? What is the reason for that silverish color? Is it made up of silver? No. Inside iron is there. It is galvanized with zinc. That even pipes also, some types of pipes also, water pipes, they are called as GI pipes, galvanized iron. Understood, students? What is the main reason? To stop corrosion. Why only zinc? It forms a layer which doesn't falls down like iron oxide. So that's why better is zinc. Next, electroplating. Electroplating is also one of the process to prevent corrosion. Mainly, for example, bicycle handles are there. Yes or no? Steel, it looks like steel, glass, or tabs are there, some types of tabs. Door handles are there. Yes or no? They are not pure steel. Inside iron is there. They are electroplated with tin and other metals. So that's why the particular material remain as it is, long lasting. All these methods are employed to increase the lifetime of iron. How can we increase? By coating on the iron. Understood, students? Right. So these are the process non-metals. So students, you already know what are metals, right? What are metals? Metals are the elements. I'll ask one question, answer students. H2O, is it a metal or non-metal? Water, is it a metal or non-metal? First of all students, why I ask this question is because this classification is not for compounds. Metals, non-metals classification is for elements only. Is for elements only. 118 elements are there, students. So some elements which are malleable, ductile, sonorous, lustrous, they are called as metals. And the elements which are non-malleable, non-ductile, non-sonorous, non-lustrous called as non-metals. Understood? Simply these elements are non-malleable, non-ductile, non-sonorous and non-lustrous. You already know the meanings of all these factors which we discussed in the previous video. So occurrence of non-metals. Some non-metals are found in the free state like helium, neon, argon, etc. And some are found in the free and combined state like sulfur and phosphorus. For example, these elements are, students, mostly they are noble gases, not exactly they are non-metals. They are comes under a separate category as noble gases. And when it comes to the pure non-metals, some are available in the free state and some in the combined state also. Examples, free state means hydrogen gas, hydrogen combined, that is also combined, but same element, hydrogen, fluorine, oxygen, nitrogen. With other elements, combinations are like many are the carbonates, sulfates, yes or no, H2O to hydrogen and oxygen. So by combinations also they are available. So what are the physical properties of non-metals? That means why we are calling them as non-metals? What decides that? Non-metals may be solids or liquids or gases, right students? No, like most of the metals are, what is the physical state? They are all solids, majority. There is one liquid metal, that is mercury, yes or no? And when it comes to the non-metals are available in all the three states, solids, liquids and gases. What are solids? Carbon, sulfur, phosphorus, these are solids. Iodine. What are liquids? There is only one liquid non-metal, that is bromine, is the only liquid non-metal. Mercury is the only liquid metal, you have to remember that. Next, what are gases like fluorine, chlorine, oxygen, nitrogen, yes or no? All these, hydrogen, these are all the gaseous non-metals. So non-metals which are solids are brittle. Diamond is the hardest, it is an exception. In general students, non-metals are brittle in nature. Brittle means they can easily breakable. Most of their powdery substance if it is a solid. And except diamond is an exception because diamond is made up of carbon sigma bonds. That makes it is one of the hardest, and its arrangement of atoms. Non-metals do not have lustrous, some have dull luster. What is lustrous nature? Shiny property is called as lustrous nature, yes or no? Do non-metals have this shiny nature? No. What is the color of carbon? Black. What is the color of sulfur? Yellowish in color. Yes or no students? What is the color of iodine? Iodine has some exception. It has kind of lustrous nature. Iodine is purple in color. Yes or no? Bromine is a brownish color substance. So, and gases, they don't have any color. So they are available in different colors, but mostly they are not lustrous in nature. And non-metals have low melting points. Metals have high melting points, yes or no? And these non-metals have low melting points. Why? Because these are molecular substance between molecule and molecule. Due to the absence of strong intermolecular force of attraction, they have less melting and boiling points. So non-metals are not malleable. We already know. Okay, can we make into a thin sheet a carbon into a thin sheet? No. A sulfur powder into a thin sheet? No. Oxygen into a thin? No. Understood? Got the clarity? Exceptions are there. Recently developed carbon fiber is one of the exceptions, sir. No. Non-metals are not ductile. Obviously, we cannot make into a wire. Non-metals are bad conductors of heat and electricity except graphite. Listen, this point is very, very important, students. Metals are good conductors of heat and electricity. Yes, sir. No. For what reason? Metals are good conductors of heat and electricity because of the presence of free electrons, which I explained in the previous video, right? Free electrons, the electrons which are ready to lose, almost there in the like lost electrons, but they are there only, okay, in that arrangement of metallic lattice. So, but here due to the absence of these free electrons, what is the nature of non-metal? They show tendency to lose electrons or gain electrons. They show tendency to gain electrons, and how the electrons freely move. Understood? Due to the absence of these free electrons, non-metals are bad conductors of electricity except graphite. What is graphite? Graphite is an allotrope of carbon. It is also made up of pure carbon. Then why it is conducting? Why? Because graphite contains one pi bond. What is pi bond in the chemical bonding? Coming here, you can get the clarity, student. This pi bond is the reason for the electrical conductivity in graphite. Non-metals are not sonorous. If you hit a carbon, Does it make any ringing sound? Sulfur powder, any ringing sound? Oxygen, ringing? No, right? So reaction with oxygen. So we are entering into the chemical properties of oxygen, right? First reaction, chemical properties of non-metals. First reaction with oxygen. When metals react with oxygen, what do we get? Metallic oxides. I said clearly. What is the nature of metallic oxides? Metallic oxides are basic in nature. Here they are non-metallic oxides. Yes, sir, is there any change? No, metal plus oxygen, metallic oxide. Non-metal plus oxygen, non-metallic oxide. What is the nature of non-metallic oxide? If metallic oxides are basic, non-metallic oxides are acidic in nature. Sulfur plus oxygen gives rise to sulfur dioxide. And this sulfur dioxide plus H2O gives rise to sulfurous acids. Metallic oxides plus water gives rise to hydroxides, which are bases. Yes or no? In the case of non-metallic oxides, we will get acids. Understood? Metallic oxides are basic, non-metallic oxides are acidic. And these non-metallic oxides in water, they produce direct acids. And here sulfur dioxide is given. If it is a nitrogen dioxide plus water, what we can get? Nitric acid. If it is a carbon dioxide in water, carbonic acid. So like the non-metals react with oxygen to form a non-metallic oxide. These oxides are acidic oxides because they react with water to form acids. Reaction with water, in general, non-metal student, they do not react with water, so there is no reaction. Reaction with acids. First of all, these non-metals, they form acidic oxides. So in general, they do not react with acid, but we have an exception. Wherever there are exceptions, you have to focus on that point. Sulfur reacts with nitric acid, releasing sulfur dioxide gas and nitrogen dioxide gas and H2O. Why? Why it is reacting? Why? Because students, nitric acid is the best oxidizing agent. That's why it is reacting. So some non-metals like sulfur react with concentrated nitric acid to form sulfur dioxide, nitrogen dioxide and water. This is very, very important reaction. Sir, why it is not reacting with sulfuric acid? Why only nitric acid means? What is the reason? Nitric acid is the best oxidizing agent. That's why it is reacting here. So what are the gases released? Sulfur dioxide gas and nitrogen dioxide gas. So lastly, uses of non-metals. Like we also discussed about the uses of metals. So here, uses of non-metals. So first, sulfur, where the sulfur is used? Yellow color powder. It is used for making sulfuric acid, H2SO4, and the salts of the metals. Sulfuric acid, where the sulfuric acid is used? Sulfuric acid is used, students, in many organic synthesis reactions. Yes or no? What is the nature of acid? It releases H plus ions. If it releases H plus ions, what is the use? That H plus ion is adopted for many chemical changes in organic synthesis reaction. So sulfuric acid as well as the salts of the metal. That means if this sulfuric acid when reacts with metal, it produces the respective salts: sodium sulfate, magnesium sulfate, aluminum sulfate, and most of them can be used as a fertilizers also. Right. Next, oxygen. It is used for respiration by living things, burning of fuels. As an oxygen is one of the key element which supports combustion reactions and respiration also. That is the element of life, oxygen. So nitrogen, it is used for making ammonia, which is used for making fertilizers. Nitrogen is one of the key elements, students, where a plant can synthesize protein because of nitrogen only. Proteins are nitrogenous compounds. So hydrogen is the best compound, students. Hydrogen is used for making ammonia, which is used for making fertilizers as fuel in rockets for welding purpose also. Ammonia, what is ammonia formula? NH3. Nitrogen, N2 plus 3H2. What is ammonia? For synthesis reaction, N2 plus 3H2 gives rise to 2NH3. So where this ammonia is used as a fertilizer, and ammonium salts are also used as fertilizer for the growth of the plants. Yes or no? For the production of this ammonia, nitrogen gas is used, even hydrogen gas also used. Hydrogen is a cleaner fuel. It is the best fuel, but unfortunately in our atmosphere there is less percentage of hydrogen. That's not unfortunate, fortunate only. Otherwise, big explosions will take place in our air. So why? Because it is highly calorific. It has high calorific value, students. Highly combustible gas. So it is used as a fuel in rockets for welding purpose also, because like the same point I have said, high calorific value, more energy it will produce by combustion. So next, chlorine. It is used to kill the germs in water. So yes, chlorine acts as a disinfectant. It can kill the germs. Like we are drinking water. Nowadays in the cities we are drinking all chlorinated water only. Yes or no? If water was there for so long, what will happen? All the zooplankton, phytoplankton will grow, right, students, under the stored water. So they add chlorine. If anything bacterial, viral growth is there, it will be dead. But high chlorine content is also not good for health. Chlorine is the one of the element which causes cancer also. So iodine, it is used as a tincture of iodine. Famously in the market is called as tincture of iodine, where iodine is dissolved in alcohol, is called as tincture of iodine. For example, have you suddenly, if you are wounded, mostly happens in the childhood days, they'll add some like yellowish color, brownish yellowish color liquid with the cotton. They will say, sir, no, what is that? That is, you can feel that like effect, like some painful effect, right? So that is tincture of iodine. So which is, it is an antiseptic. So that these are all the uses of non-metal, students. So what we discussed in this video, and we have metalloids also. What are metalloids? The elements which have properties of both metals and non-metals are called as metalloids. If you see the periodic table, these elements are like arranged, a line of elements, like a zigzag arrangement. They have both metallic and non-metallic. Sir, how an element can have both metallic and non-metallic? Not in terms of their valency, not in terms of their any physical properties, students, in terms of their hydration enthalpies, atomic sizes, attractions, the ability to solubilities, everything, all the factors which influences for these metalloids exhibit properties in between that of metals and non-metals. In the periodic table, the metalloids are placed in a zigzag way and separate the metals and non-metals. So the line of elements which separates metals and non-metals are called as metalloids. They have both metallic and non-metallic. The elements are metalloids: boron, silicon, germanium, arsenic, antimony, tellurium and polonium. Polonium is radioactive. These elements have both metallic as well as non-metallic nature. Lastly, inert gases. Students, like I said, inert gases, the last group elements in the periodic table, 18th group elements, they are called as inert gases or noble gases. What is their speciality? They are all gases and they are chemically unreactive. Why they are chemically unreactive, students? Why? Because they have completely filled electronic configuration. That's where chemically unreactive. Helium 1s2, neon 2s2p6, argon 3s2 3p6, krypton 4s4p6, completely filled or not? They are chemically unreactive. That's why they are called as inert gases. So that's it. These are the elements. They are also called as aerogens because they are all form air. Gases form air. Sir, no. Zero group elements. Why? Because their valency is 0. And examples: helium, neon, argon, krypton and xenon, radon. That's it. These are the classifications of elements into metals, non-metals, metalloids and noble gases. This chapter is very easy chapter, students. But there are some clarities, some points like why metals are conducting electricity, why non-metals are not conducting, they are bad conductors of electricity, some reactions, which is acidic nature, which is basic nature, corrosion, rusting, these are the points you need to focus on. Alloys, the composition of alloys. So these are the main points in this chapter. I hope you got the clarity, students. Thank you.